Okay, so to help you out with your properties of transformation, to get ready for the mastery test, I just want to review a few things, and then feel free to go back to the video to help you as well during your mastery test. This is difficult and new information for you. So, all right, to review, let me just click here so I can write on the screen. Some things that are important when a figure is translated, and again, that's just another word for a slide. It's orientation, so that means like the direction that it is remains the same, and the measure of its angles also remain the same. So for example, if I have a triangle, and let's say it's triangle ABC. If I slide or move that triangle, its orientation, so the direction that it is, stays the same. It didn't turn at all, and all of the angles remain the same. So that's just something to remember on when a figure is translated. All right, this is another good example here. Quadrilateral ABC, so this first one, and just a reminder, your first point, you start with your first point. Once it's translated, we then label the next point A prime. That's what that little mark means up there. And then if it gets translated again, we call it A double prime. So that's what all those little markings mean. Like this is your original image. So our quadrilateral ABC undergoes a what to form quadrilateral A prime, B prime, C prime, D prime. How did we get from this triangle, this quadrilateral to this quadrilateral? Well, I can see it looks like it's flipped and it's going over this x-axis here. Whoops, I'm not doing a very good job. All right, so it looks like it's a flip over the x-axis. So we can fill that out. It's a reflection across the x-axis. All right, and then to go from quadrilateral ABCD to the double prime. So to go from here to here, how did we move? Well, it looks like the orientation stayed the same because this point A stays on the top here. So I can tell it's a translation, a slide. So we just need to count how many over, and then it looks like down. So we are moving 1, 2, 3, 4, 5, 6, 7 to the left, and 1 down. So that one was a translation. 7 left and 1 down. Just another something to remember when a figure is rotated, and so that means it's going to be turned, its angles will stay the same. So the shape itself stays the same. Orientation may change. So that means just the way that it's turned. So for instance, here again I have, let's say, my triangle ABC. But if I'm going to turn it, I may turn it on its side. And so now I may have, if I were to turn it or rotate it, now A might end up over here, B here, and C. So it's still the same triangle, the angles, the sides, everything stays the same, but the orientation is what changed.
No, you have no speakers.
All right, Another good review. This one here, it says, rotate this triangle on the graph 90 degrees counterclockwise. If we are going counterclockwise, we are going to the left about the origin. And we're going to determine the orientation of the triangle. We're going to pick the triangle and place it where it belongs. So a couple things, you can Google and look up a rule for a 90-degree counterclockwise rotation. And the rule for that rotation is that your point XY is going to change to negative YX. So that means the X and Y flip, whatever your Y value was is going to become the opposite. So using these rules can really help you. So like, let's say if I start with this point here, that is -2, 3. Whoops, hang on. So I have -2, 3. So the X and Y are gonna flip. So it'd be 3, -2, and the Y is gonna become the opposite. So in this case, it's gonna become a negative. So that's gonna go -3, -2. So that point will now be here. All right, let's do another point. So that one is -4, 5. So again, to do this 90-degree counterclockwise rotation, the X and the Y switch, and then the Y changes to the opposite sign. So now it's -5, -4. So that point would, after it's rotated 90 degrees, so it's kind of like, you know, turning it. You can kind of almost think your X and your Y rotate around. So it's rotating around 90 degrees. And then we have this last point here. That would be, that's going to be -5, 0. And so the X and the Y will switch, 0, -5. 0, I can't change to the opposite. 0 is just that number that stays neutral. So that's going to be my new point once it's rotated. So I would stay at 0 and go down to -5. All right, so once that triangle is rotated, it's going to look like this. And so you're going to want to drag. It looks like this one would match up perfectly. You're going to want to drag that triangle into that location to match up. All right, and a couple more. Again, these are just going to help you with that mastery test so that you can do your best on that. All right, a figure is reflected. Reflected is another word for flip. So it's going to flip across the x-axis. So we're going across this axis here. And what is the orientation of the reflected figure? So we just have to kind of pick up or pick which shape is going to match. The best way to do this would be trying to think, well, if it's going to flip, this is going to flip upside down. So it's going to be this shape, but upside down because it's going to go across that x-axis. And if we look down here, which shape it ends up like upside down? So it's just this shape, but upside down. That looks like it's going to be D. So it's that one that ends up upside down. All right, what type of transformation does shape A undergo to form shape B? So I go from A to B. It looks like it's a rotation. It definitely turns. And we are going 90 degrees. I can kind of see that I go over that one quadrant. And I am going to the right, which means I'm going clockwise. So kind of the things I just said would describe a 90 degrees clockwise rotation. All right, and let's just do a couple more. This one, a triangle A is rotated around 180 degrees counterclockwise. If we're going counterclockwise, we're going left. And you can think I'm going to go, when I go left, 90 degrees would put me in this quadrant, and then kind of turn another 90 degrees to make 180. It's going to put me up in this quadrant here. Another way, again, you can look up that rule for your 180 counterclockwise rotation. It would be taking your point, X, Y, and what happens is both X and Y just become the opposite. So like if I pick one point here, 3, -1, that's gonna, the X and Y stay in the same location, they just become the opposite. It'll end up -3, +1. So I would end up -3 over here, +1. So it just kind of confirms that, yes, my shape should be up here in that quadrant. And if I go to look at the shapes that have it in that quadrant, well, A does, but it doesn't have that point at -3, 1. There is no point there. This one does. So that is a possibility. And this one does not. That ends up just up at that first quadrant. So this triangle looks like it will be the one that is that rotated 180 degrees counterclockwise. What happens here? A figure in the first quadrant is rotated 180 counterclockwise. Again, that would be going to the left. What quadrant do we end up in? So just a little reminder about your quadrants. Here's your X and Y axis. First quadrant, second quadrant, third quadrant, because they're divided into 4s. That's why they're called quadrants. So 1, 2, 3, and our fourth quadrant here. All right, and if I start in the first, let me just put a star. I'm starting here. I'm gonna go left 180 degrees. So here would be my 90-degree rotation, puts me over in the second quadrant. And then another 90 puts me down here into that third quadrant. So C would be the right answer on that one. All right, I hope that helps. And that was a good review to get you ready for that mastery test. We'll see you on the next video.